Alright, I don't really have like any time at all, but I had this physics quiz last semester, so maybe I can help someone out. So we have this scenario. We have angle theta, and we have some sort of box, and obviously there's the force of gravity acting down, right? And I'm just going to replace it for its components. Force of gravity perpendicular, and then force of gravity parallel. This is 90 degrees. Do the trig, just trust me, this is also theta. And there's this force acting as well. And so I'm going to start with the equation that friction is equal to the friction coefficient times the normal force, right? Oh, and there's a normal force acting, I forget. Well, it's not, the block's not accelerating up or down on this ramp, so this must also mean it's equal to negative mu times force of gravity perpendicular, right? So with that in mind, we'll just keep this little thing here. Negative mu force of gravity there. And trust me when I say that the force of gravity perpendicular is just going to equal mg cosine theta. There's videos online about it. If you want to, I can make another video, but just trust me, it's all good. Alright, so this means that this is equal to negative mu mg cosine theta is equal to friction. So what can I do with that? Well, what I do is I'll just write up this equation. The sum of the forces equals mass times acceleration, right? Obviously, these forces will cancel out, so I really just have force of gravity parallel and the friction. So I'm going to write that down. Force of gravity parallel plus friction is equal to mass times acceleration, right? Well, I also, I know what, how do I straighten that up? Parallel. We found another way to write friction. So I'll write it minus mu mg cosine theta, right? And trust me when I say it, the force of gravity parallel is equal to mg sine of theta, right? So what I have here is that mass times acceleration is equal to mg sine theta minus mu mg cosine theta. This is good, very good. Because what we have here is, I'll rewrite it like this. Mass times acceleration is equal to mass times g sine theta minus mu g cosine theta, right? So what I just did there is I factored out the m on the right side, and if we were to divide both sides by m, we get that the acceleration is just going to be equal to g sine theta minus mu g cosine theta, right? So I can have that negative mu g cosine theta is equal to the acceleration minus g sine of theta, right? Alright, almost there. And the home stretch now. So I can divide by negative g cosine theta on each side, and I get that mu, or the kinetic coefficient, whatever you want to call it, is going to be equal to the acceleration minus g sine theta over negative g cosine theta, right? And when I did this, I just assumed g was actually a positive value. It was going down the ramp, and so from the video, the acceleration was about 5 meters per second squared, right? And the theta was 45 degrees, and we didn't even need to know the mass at all. So This means that this is equal to 5 meters per second squared minus, I don't know what g value he used, I forgot. I'm just going to use kind of the universal one, 9.80 meters per second squared times sine of theta, 45 degrees. Now I'm going to do that over negative 9.80 meters per second squared times cosine of 45 degrees. So I'm going to do this on my calculator real quick and just kind of see what I get. I get, so 5 minus 9.80 sine of 45 over negative 9.8 times cosine of 45. Alright, I get approximately 0.28, and this is unitless by the way, because these will end up canceling. So I get that the mu sub k is equal to 0.28 whenever I do that. And let's see if it matches. And if you see in the background here, it does end up matching 0.29, 0.28. It was just a rounding thing. But the important equation here that you really need to know is that mu sub k is equal to the acceleration minus g sine of theta all over negative g cosine theta. And for this, plug in a positive value for g. Don't put negative 9.8. Just put in the positive value. And what I mean by the theta is this guy right here, right? And the acceleration you can get from a motion detector, or they give it to you, or whatever. This block's going to accelerate downwards down the ramp. Then acceleration, that's the acceleration you use. I should draw that in my free body diagram, but yep, there you go. Let me know if you want any other vids. So yeah, thanks.